In this video, we are going to look at the average rate of change of a function. And the average rate of change between any 2 points on a graph is just the slope of the line through those 2 points. So over here, if I want to know the average rate of change between this point and this point here, if I draw a line through those 2 points, I'm just finding the slope of that line. And that line is known as a secant line. So here's your formal definition. If you're asked for the average rate of change on a given interval of your domain between x1 and x2, you're plugging those values into the function. You're finding the difference in those y values over the difference in those x values. So it's really just the slope of a line that you learned back in Algebra 1. So this first function, f of x equals negative 2/3 x plus 2, is actually a linear function. So one of the properties of linear functions is that they have a constant rate of change. So regardless of what interval you're given, we're not going to overthink this. The slope of this line, well, this is in y equals mx plus b form, but I can confirm it by counting my vertical change over my horizontal change, and the slope of my secant line is 2/3. This next function is a quadratic function, and first I'm supposed to find the average rate of change between -1 and 2. Because I have this nice graph over here, I'm going to try to sketch my line that goes through -1 and 2, and I kind of missed it just a little bit right there. So this would be the secant line, so I'm finding the slope of that secant line. Now just by looking at it, it looks to me like it is about 3. But I'm going to actually verify this algebraically, especially because you won't always be given such a nice graph. So what I'm going to begin by doing is plugging both values into my function and algebraically getting the y value. And when I substitute, I get 0. And when I plug in g of 2, I get 9. So I have 2 ordered pairs here. The first ordered pair is -1, 0, and the second ordered pair is 2, 9. And now all I'm doing is finding the slope of the line through those 2 points. When I do that, I get 9 minus 0 over 2 minus -1, which would be 9 over 3, which reduces to 3. So my average rate of change here would be 3. All right. Now I'm going to find the average rate of change on a different interval. I'm asked between the interval 0 to 5. So on the graph, just so you could see what it looks like, I know my average rate of change is going to be negative this time. It's downhill. It might be -1, but it's shifting just a little bit. And again, I don't always have such an accurate graph, so let's figure this out algebraically by first finding g of 0. And secondly, finding g of 5 to get my 2 points. So when I plug in 0, I do get 5. And when I plug in 5, I get 0. All right, great. So my 2 ordered pairs, my first one is 0, 5, and my second one is 5, 0. And I'm going to find the slope of the line through those 2 points. So I subtract my y's over my x's, and I do get a slope or an average rate of change of -1.